Good morning, everyone. My name is Patrick Farage. I'm your moderator for the session today. I'm the chair for the DNO Committee, Deployment and Operation Committee at the FTTH Council. I would like to welcome you this morning for this very interesting session titled Active Equipment Solutions and Architectures to Maximize the Benefits of FTTH Networks. Over the last few days, the last 2 days, in workshops but also in sessions, there was a lot of interesting discussions and conversations, roundtable conversations around open access and how it helps efficiently bringing fiber to everywhere. So this panel will explore different approaches to do that, such as open access, open broadband, that eventually will cost efficiently and most importantly in a sustainable way help bring fiber everywhere. Providing subscribers with fair and freedom of choice and offering providers with a fair chance to showcase their services. Moreover, with the need for speed forever growing, we will hear about the evolution of standards towards 50 GPON, but also we will explore different ways to bring high speed to everywhere in the home and enhance the end user experience. Let me quickly introduce our panelists. Kaisa Adversson is the Chief Marketing Officer of the Genexis Group. In her over 20 years long career in the telecom industry, Kaisa held various senior marketing and market development roles in leading organizations such as Nokia and Ericsson. Next to her, Dr. Mitya Golia is a business development director at Kontron's business unit, Broadband. He is responsible for new market strategies and go-to-market initiatives for the new technologies. Mitya brings 15+ years experience of global operating in the broadband networking industry and a deep passion for product business development and strategy to Kontron. Next to Mitya is Dr. Markus Brunner, is Chief Expert Standardization at Huawei. Markus is active in research, development, and standardization with detailed experience in a variety of fields, internet, cloud, and 5G. He is also contributing to various international organizations on future networking technologies, including ETSI, ISG, F5G, and the World Broadband Association. He's the work group chair there. Last but not least, Erik van Ouden has long experience in the world of fiber optic networks. He's the country manager of Netherlands in AVM. His experience ranges from design of the physical infrastructure to the actual protocols now used in FTTH. Erik has a technical background in tele and data communications. He has been working at AVM since the year 2000, and his responsibilities include AVM's commercial activities within the provider world in the Netherlands. Welcome to our panelists. I'd like to invite Kaisa on stage to kick off the presentation.
So, take a trend and explain how you support it. I choose the open access model. And for those who have been here for these days, you know that that was an open door to run through. It's such a big trend right now. As Patrick said, I'm Kaisa Arvidsson. I'm the CMO of Genexis. And for those who don't know us since before, we are a Swedish company with headquarters in Stockholm and in Holland. We have over 20 years experience from the fiber to the home industry and broadband. We are about 200 employees spread over 10 offices in Europe, working in a global network of partners and distributors, and being one of the leading CPE vendors of Europe. It's a strong belief that the broadband starts in the home. So when we put our innovative culture to work every morning, that's where we start to work and see how can we make it effortless? How can we bring households with internet services in an effortless way and do it with sustainability at the start of design of every product. We are strong believers of openness, interoperability, following standards, and a strong collaboration among the ecosystem, as you will see further on in the presentation. So, what is an open access network model? And what are the big benefits? Well, in short, it really comes down to offering wholesale on equal terms. And if we quickly look onto the value chain of the open access network. So you start with the dark fiber, the owner of the fiber. In countries, for example, like Sweden, you can wholesale already here. Then, as those who were on the excellent presentation yesterday on open access fiber, you know that the communications operator role is super important. That's why we activate the fiber. This is where we have the IT infrastructure platform. This is where we really make sure that all the service providers that will buy and operate on the fiber have equal terms to operate. And they also need a very consistent environment to operate upon. And to have a multitude of service providers addressing the homes is critical for what's been asked for in session after session throughout the days here, to really build attractive offerings for households which they want to buy and which they feel appealed to. This is worth the investment. It brings quality to my life. It makes things easier. And if we look on the benefits of the open access network models, well, when you let each part of the value chain focus on what they are best at, you can have very rapid deployment. Service providers don't have to wait while they figure out how to roll a fiber, but they can operate on the existing platforms. To really have competitive offerings to households, because that's needed to keep their interest, you need innovation. And you need innovation on all the layers. And innovation also brings cost efficiency. And all these together makes the coverage of services, but increasingly so of fiber, much better. And I wouldn't be here being Swedish without taking a little example from my own homeland, as it is referred to so often as one of the key models for how to drive an open access network. And I think one thing that is really standing out in Sweden is the key role of the municipalities. When we started in Sweden to invest heavily in fiber, already in the early 90s, there was quickly a strong movement that we can not only have vertical offerings, but we also need some who work on the horizontal. So we get innovation and competitiveness on each of the layers. And by engaging and making it possible for the municipalities to roll fiber and engage communication operators onto their fiber, we see today that we have over 85% coverage of our country. We have an uptake of over 80%, even though we have so many who works in the mobile industry, which have included me, and then penetration of more than 70%. So I have to change the almost since yesterday when we got the new panorama. And almost 100% of the municipalities in Sweden are offering both dark fiber and wholesale on layer 2. And when we see the increased fiber deployment investments in Sweden, there have been several of reports or surveys to see, so was this engagement from the municipalities and the encouragement of them, did they speed up the market or did they slow down the market? And the conclusion is that this heavily speeded up the market and the deployment of fiber. One conclusion in these studies is also how important it is that the managing of the fiber is made easy and that it is consistent. So to make it easy for service provider not to have different terms and conditions, different setups in each city and on each network that they engaged on. And we also see one thing that sticks out is how the municipalities in Sweden have organized themselves in the Swedish Local Fiber Alliance, which is quite politically active lobbying. It advises its member, it helps with templates to sort how to set up things, etc. Just concluding my little own experience. So I come from a fairly small village, 12,000 inhabitants. That's not a lot. But if I look at my parents' house, they actually have 11 service providers offering them their services, packaged in over 100 different packages. So they can choose from 30 euro a month, 100 up and 100 down, to 150 euros per month, having 1 gig up, 1 gig down, and 78 channels, including premium sport channels and a router. So the spread where they can choose is really amazing for such a small village. And if we look on how much of the fiber does the municipalities own? In Sweden, it's about 60%. And if you compare that to the panorama of yesterday, the average in Europe is 5%. So a big difference. So if we look on some recent examples, and this week I've shown many of them, I picked a few just to see that on different markets we really see the uptake of the open access model. You have in the UK, there was a very good panel with City Fibre yesterday. We see the Virgin Media O2, who announced that they have this NetCo open access network launched as a subsidiary of their company, making going more or less head-to-head with the incumbent, and also giving a little indication to the altnets that they will also impact on their abilities further on. In Poland, we see Fiber Host and we see the Open Alliance Foundation all announcing the expansion of the networks. If you were here yesterday, you saw the Danish OpenNet platform. They communicated that they have engaged with 5 of the big Stadsnetwork in Schleswig-Holstein, enabling a common platform for all the service providers that want to address the proactive homes here. And to go a bit over the Atlantic, we also see that BlackRock, together with AT&T, has formed a joint venture, Gigapower, to offer open access network in the United States. So how can we, from the part of the industry where Genexis is active, be of great value for the open access networks? Well, if we start in the platform of we need affordable, attractive broadband services for households and for enterprises to build up a more digital Europe, we see that as fiber coverage is built out, infrastructure is likely to consolidate. That is what happens in infrastructure. And when they consolidate, it has to be prepared for this. And one critical point that we see is that the PON networks need to be interoperable. So that's why all our ONTs are interoperable with any OLT, making it smooth when you see M&As in the market, that you don't have a sudden stop because you have to change all the ONTs or you have to mix and match. It's also important if you start to collaborate, and we also see some market regulations where you are asked or required to have more than one OLT vendor. And of course, you don't want to have more than one ONT in your bus when you go out and fix something. As broadband coverage is maturing, we also see more and more focus connecting homes. And I think that is one of the big themes this week, right? Not how to have homes passed, but homes connected. And then it has to be effortless. There has to be like one FTU that you can terminate the fiber in, waiting for the subscriber to decide what service provider or what setup they want. It has to be something they can install themselves. And it must be easy for service provider or for subscribers to change service provider. This is by the essence. It's made easy on the portals where you choose service provider, but you don't want the service down in the network. So from us, it's why we launched not only, since previous we have 1 gig plus 1 gig WAN in our ONTs, but we now also have 10 gig plus 10 gig ONTs, so that the subscriber either can have 2 activated at the same time, but you also just go down in the basement and move the cable from one connect to the other, and you would have about 3 seconds of service down instead of maybe 2-3 days. And then service provider must be able to launch new services quickly and segmented. That's in the essence. And how do you do that? Well, as in every router industry we've seen over the past 10-15 years, you are starting to separate the hardware from the software so you can have one software layer to address, making it smooth and efficient to launch new services, segmented, not based on what router you have, but based on what behavior the family has. Some examples of what we do in this, and if we start with the software then in the software layer, we have our nominated for awards this afternoon, let's see, IOVRT software, which is built on OpenVRT, so open source SDK, enabling either you to, a service provider, to enjoy our contribution. We built software upon it, which is easy to populate with new software services, or you can buy the SDK as it is and do like British Telecom, who built their whole new portfolio based on our SDK. We do it with our dedicated work with the PON auto sensing that is part of the TrueTalk software, so that you would have one ONT for any OLT in your network. And we also enable then the 2-port to 2 times 10 gig ONTs for quick change of service provider, also physically. And with that, I would like to hand over to the software-defined part of the network.
Thank you.
Thank you.
Very well. Very good presentation, Kaisa. Thank you. Welcome also from my behalf, so from my name. My name is Mitja Golja. I come from a company called Kontron, and I would like to speak about open broadband. So Kaisa presented open access networks, so how we have an open business principle, how we have a topology that can separate service providers from network providers. I will focus more on the technologies that can enable to have more efficient network elements, also based on the open principles. And with such principles, the operators can reduce the costs. They can make their FTTH networks more efficient. But let me start with a couple words about Kontron. So I come from Kontron, Slovenia. This was former Iskratel. Now we are part of much bigger Kontron group. So it's an Austrian company focused a lot to the IoT segment, but we have also the broadband solutions. And it's important that this is an European company with European development and production. And we are providing end-to-end solution for broadband networks. So we have the central office equipment called under the brand name of Lumia, where we offer different types of optical access. And we have also family of products for the CPE segment, so for different type of access, of course, supporting all the latest technologies. Let me start with some global trends that we are perceiving, and I'm quite sure that many of you, if you come from the operators segment, you see similar trends. Internet traffic is growing, so roughly with around 30% per year. Majority of that growth comes from the different video services, so mainly over-the-top providers. And we also see that those traffic is mainly consumed on mobile devices. Smartphones, tablets are today generating the most internet traffic. And this will continue to do also in the future. So, and this is then, of course, impacting also to the operators' networks. Operators, if they want to offer services in the future, they have to constantly invest, introducing new technologies, upgrading the network to support higher speeds, higher capacities of the network. And if we look the typical investment from a telecommunication operator, they have to invest on the side of the network at home, so the CPE devices, because it's more and more services using the Wi-Fi. We have constantly improved Wi-Fi performances, so by introducing also the new standards. So we are now migrating from Wi-Fi 6 to Wi-Fi 7. The pace is quite quick, so every 3 years, practically, there is a new standard. Then, of course, we have to upgrade the optical network. So we are migrating today from GPON to XGS-PON, later to 50 gig PON, and so on. And this is also a significant investment from the side of the operator. And correspondingly also upgrades in the aggregation and transport network has to be implemented every year. And even in the core of the network, of course, the BNGs has to support higher capacities. Operators are caching the content of video services through the CDNs. So this means that it's a constant investment on the side of the operator. And it's not just the investments that are increasing the cost, so buying new equipment, new licenses, and so on. It's also the cost of the support, of maintenance of the network, operational expenses. So, and everything what was presented, so it's going with a pace of like 30% increase every year. And this brings a challenge to the operator, because on the other hand, the revenues are not increasing 30% per year, and operators are, of course, pushing the vendors how they can make some savings, how can they lower the cost of new equipment, new licenses, and so on. And that's why in Kontron we are proposing an initiative, a solution called Open Broadband, how to optimize the investment costs, how to optimize the operational expenses when you are upgrading the network to support higher speeds. And we see 3 main principles. So the principles that were implemented also in other industries. So, of course, if we want to control the costs, if we want to lower the investment, we have to have an open solution. So, and that means that we have to work with standards. Standards that are defined in the industry, that we can make the equipment interoperable. The second very important principle, which is used widely today in many industries, is cloud technology. Using virtualization, using cloud technologies can significantly drive the costs down. It's very scalable, it can support new business models, quick introduction of new services, and so on. And by using those principles, we can make a solution that is future-proof, that will keep with the demand of increasing capacities and introduction of new applications, new services, new business models. And we see that this principle, this solution of open broadband can be implemented in 3 main network elements. So if we start from the right, so open CPE, how to make a CPE more efficient, more open. And CPE is a significant investment on the side of the operator. Then in the part of the access network, so we are proposing a software-defined access solution to optimize the investment costs. And on the side of the core network, we are proposing of using the virtual BNG. So let's check all these 3 segments a little more in details. Open CPE. So we have challenges of constant upgrades of the Wi-Fi standards. So from Wi-Fi 4, 5, 6, 7, I heard that industry already started collecting ideas what would be in Wi-Fi 8, and even the Wi-Fi 7 is not fully standardized yet. We have the products already on the market, but standardization takes some time. And operators are facing those challenges. So constant improvements of the devices, how to ensure good interoperability among different vendors. Every vendor has slightly different look and feel. How is the navigation on the device, so user experience and so on. And of course, they are spending a lot of efforts when they are testing, implementing, introducing new vendors in their network. So it's a constant work they have to invest. And we propose here a principle which is very well known also in some other products like PC. We are separating their hardware from software. So it's not necessary that those things are 100% bind together. So if we do the same principle also in the CPE, so that we can separate the hardware part from operational system and applications, then we can have significant savings. Savings on the CapEx part, so the cost of the product at the end, but also we can lower the costs, the operational costs. So by having a single software platform that runs on different hardware, the operator can reduce the testing, they can easily integrate a new vendor into their network, they can easily integrate new applications. They will have the same look and feel on various hardwares from various hardware vendors, and that will bring also significant improvement of user experience for their end customers. And by using a single application, single protocol stack, they will have also much less problems with the interoperability. So this is one very important principle, and it's already today implemented at several operators. So several vendors are working in such way. There are several companies supporting such principle, and we believe that this is a way to go forward. Then about the access part. So by using virtualization in the access segment, we can also improve significantly how much the devices cost and how much does the operator need to invest when introduce a new vendor in their network. So a conventional network looks like a silos, so vertically integrated, where you have the end device, OLT, management, and on the top, integration to the OSS BSS system. By introducing a centralized SDN controller, the operator can significantly simplify introduction of new OLTs into their network. Of course, those OLTs has to be designed in such a way that they support open standards, so that we have standard interfaces and then the SDN controller, also through the standard interfaces, is just one time integrated to OSS/BSS system. By this, they can reduce the costs of implementation of their network. It's easier to introduce also new services, new models, supporting like also open access network, wholesale, and so on. And by using this principle, they can also improve interoperability, because in this SDN controller, it's a single protocol stack, single application. You can achieve much better interoperability among various ONTs. And by using this principle, we see by the projects we are working there that the costs can go down between 20 to 40% on the CapEx side and around 20% on the operational part. There are two standardization bodies covering this segment, so former ONF, now Linux Foundation, and we have Broadband Forum, who are defining the interfaces, the protocols, how OLTs should communicate with an SDN controller and how the SDN controller should be connected with the OSS/BSS system. And the third network element, the virtual BNG. So BNG as the brain of the network, a very complex, expensive network element. We have come to the point that we need to virtualize this network element. And by virtualizing the BNG function, we can also distribute it. Because by using the cloud technology, we can easily scale this, and VBNG function can run also on the lower network elements, on the traditional x86 servers, or even on the OLT. By using this principle and pushing the BNG function lower to the network, the operators can save their investment of upgrading the uplinks, because they can push also the CDN lower, the caching servers. And that means that they don't need to increase the uplinks capacity by 30% as the internet traffic is growing. Majority of the traffic comes from the video services, which are typically cached on the CDN servers. So, and further on, if we add some important functionalities to the VBNG, like carrier-grade NAT, we can also significantly decrease the investments and also the operational part. So, to conclude this presentation, so by using those three principles, we see that we can support the operators to decrease the investment cost. And cloud technology, virtualization, openness is something that is happening today. So it's not a question if virtualization will come also to the broadband. It's just the question when and how fast. So, and you can start today. So the technology is mature enough. There are standards supporting this introduction of virtualization, and sooner the better. Then you're not alone. So there are vendors, there are system integrators supporting this open broadband principle. Kontron is one of them. So we have experiences, we have first references where those technologies that I presented are already implemented, and it's working, it's stable, it's reliable, it's scalable. By this, I would like to conclude my part, and I will pass the word to my next colleague.
Thank you. Thank you very much. You heard a lot about openness, and yes, standards are the basic thing of openness, and I'm doing standardization quite heavily, and I will basically talk a little bit from standardization to real implementation. And basically, if you talk standard, we talk about the F5G Advanced, so that's a ETSI ISG F5G group looking into that standard. I just got elected vice chair lately there. And we basically look into fiber to everywhere and everything, and for the more residential markets, and that's I'm concentrating on here, we will look into a more 10 gigabit society, 10 gigabit area. We are a bit at the beginning of that. I heard a lot of gig here, but we look a bit ahead in standardization, but still it's starting from now onwards, it's implementable. So let's see, F5G stands really for fixed 5G. And why we called it like that is we basically have the similar intention like the mobile people. We basically have the different generations of fixed line networks, and we are now at the space where we have a lot of different applications. We have the applications in the homes, in the enterprises, in verticals, in manufacturing, in health, and so on. So you have a whole plethora of different applications, and we need to be able to handle all that applications. So we basically are now at the stage of F5G Advanced. It's sort of an evolution of F5G, which we're currently in process of doing. So technology-wise, this means Wi-Fi 7, 50G PON, 800 gig per lambda WM. Just give you a bit of a hint from an underlying technology perspective where that goes. So this F5G Advanced generation, we basically set up several dimensions of what we try to tackle. Naturally higher speeds, you heard about that already, but we want to be more green, so a more green and agile way of doing the network. Then we have real-time resilient link capability that specifically if you go fiber to the machine, fiber to the robot, you're going to have all types of different issues than if you go only fiber to the home or fiber to the room. Then we need for certain applications a guaranteed reliable experience. So it's very good experience, but also reliable experience and guaranteed experience. If you have a fixed network, basically your more enterprise customers have different requirements than your home customer or your residential customers. So that's needed there as well. We have optical sensing. That's a very interesting new area people are looking into. You can use fibers for sensing. We can sense certain activities on the fiber, like vibration, temperature change, into meter accuracy. And we have full fiber connectivity. If you have more things you connect, you have more fibers, you have more fiber endpoints. You need to look into the ODN and how you manage that. So that's the F5G Advanced Generation definition. This is the source here is an ETSI document. You can have a look at that. It's all open at the ETSI portals. So what are the key drivers for that? There are basically twofolds. One is the digitalization on cloudification of the applications. I have a few examples there. The UHD, immersive, enterprise digitalization, fiber to the machine. On the other hand, we have network infrastructure optimizations, where you will have more smartness. You want to combine computing and connectivity. You have this visibility and sensing capability, need to be more green and more autonomous. So these are sort of the two drivers. And then there are a whole lot of different enabling technologies below, which are used to basically implement this overall F5G architecture. And I don't go into detail in this enabling technology. I will come back to the 50G PON and the FTTR, because those are the ones sort of like we look from a technology side first, and we're going to look at it a bit more detail on that. So that's where we are on the F5G Advanced side. Still brought like some applications, just to give you a bit of a feeling. I mean, people always say, yeah, we don't need that. No, there are upcoming applications coming along. When there will be at mass deployment and so on, we don't know. We don't have a glass ball, but we expect things going to happen. As you see, I'm like long enough in the industry, and in every generation somebody said, we don't need that. but a few years later it was there. Don't underestimate how quick these things can come. So these are sort of like a few applications, like the cloud gaming. There you have bandwidth of 300 meg, latency below 100 milliseconds. We assume somewhere in the 300 million subscribers willing to pay for that. We have a quasi-local instant response type of application, like cloud network attached storage, this type of applications. You are more in the 3 gigabit, latency below 10 millisecond space. We expect somewhere in the 1 billion users for this type of services. You see a sort of a volume game here. We have the 8K 3D video. We call it the glass-free 8K 3D. There you have 500 meg per stream, 100 millisecond. Just give you a bit of a feeling on that this type of applications are here or at the horizon to be there. And then we have the lossless image transmission. That's more an industrial thing. We have experiments with industrial cameras. They produce 8 gig per stream. You'd usually have 4 of that camera to do quality control in industrial settings. So we believe there is a 20% year-on-year increase on this type of applications with using fiber, or you need to use fiber at that point in time. So what does that mean at the bottom line? So we have this growth of digital devices of different types. We basically expect the service packages moving from 1 gig type of service packages to more 10 gig type of service packages. And we have the service assurance and deterministic experience depending on the application, but many of the applications need a higher guarantees and more determinism in there, specifically if it comes down to latency, but also on bandwidth. So I've shown you a little bit the standards and application aspect of that. But let's move now into a bit of the technology and how we get there. So the first part is the F5G Advanced 50G-PON. So basically, there are naturally 3 deployment challenges. You want to reuse your ODN. You basically want to reuse your ONUs when need, as long as possible. And you want to reuse your OLT. So basically, these are sort of like a certain deployment challenges coming along. So what you basically see now, and 50G-PON basically allows that to do, so there is no change in the ODN needed. You can reuse whatever is there. Basically, you can reuse your ONUs, or ONTs, depending on who talks about it. Basically, there are these combo ports, or combo things here, have GPON, XGS-PON, and 50G-PON combined into one port. So that basically allows you to keep the ONUs where they are, and those subscribers who want to have a higher service, a better service, you send them a new one. So it's a very gradual introduction of the technology. Then finally, you can also reuse the OLTs. Today's OLTs are able to have like 50G-PON cards with 8 ports only. So that's for migration purposes, this is good. You can add 1 card and go with that. So it's relatively easy to do that now, to go towards 50G-PON. But we naturally look a bit ahead, and then we come to the OLTs, which we need to have higher speeds. So if you start deploying 50G-PON at scale, you need to look at the OLT. And the best example is the line rate forwarding requirement for 50G-PON. I bring you an example here. 50G-PON, if you have 50G, 10G, and 2.5G times 16 ports, you will talk about around 1 tera per card. So that the OLT needs to be able to handle. Now, if you have the whole OLT with several cards, the OLT needs to be able to handle that type of traffic. And that's why we basically announced this new OLT here. And it's basically already also ready for the next generation, which is not there yet, but the standards guys start looking into that and start thinking around what is next. So 50G-PON is there, it's standardized, so we already start looking at what's next. So what this OLT has, it really has this ultra-high bandwidth. So we have 2 tera backplane capability, so there is enough space for an evolution. We have a very interesting, and we come back a little bit on that, we have an intelligent engine, and one of this intelligence, what it's doing, it's actually even controlling some of the Wi-Fis in the homes. So you can basically have tools to autonomous manage Wi-Fis from the OLT. And then I said deterministic experience is very important. This OLT basically allows to go like a packet-based backhaul of the OLT, some sort of Ethernet type of network from there, but you can also go right away OTN with a hard isolation, very guaranteed services. So this allows to run different type of services on the same platform. Specifically, if you have like demanding enterprise customers, you can put them on the same platform and have the backhaul taking care of the guarantees. Now, if you have 50 GPON, and you say basically you have 10 gig or up to 50 gig to your home, I don't think today's Wi-Fi system are able to handle that anymore. And I don't see how this is possible to handle with today's home network architecture. So we basically need to look into that, and that's why we basically promote this fiber to the room aspect, and these products can be shown at the fair. Fiber to the room is basically you have not one ONT, but you have several ONTs. One main ONT, like a main fiber to the room ONT, and several sub FTTR ONTs, basically having Wi-Fi, and you basically have a whole home, whole area covered by Wi-Fi. This naturally enables a lot of different IoT-oriented and smart home-oriented applications. One mentioning the fiber to the room, it's a difficult beast also because like who provides it? So basically there are sort of 3 different players competing for the home. One is some sort of like the internet guys saying, Huawei itself has products there as well. You can provide home equipment, home networking equipment like that. People can buy it wherever. We see some markets, the real estate companies, do the fiber to the room deployment. So real estate is sort of like, if you have good Wi-Fi, it's a sales point for your real estate. So it's part of the whole package. So real estate is interesting in that. But operators, we feel they have sort of the best knowledge also from an operational perspective. So that's why the operator side, and that's at least the Chinese operators have chosen that model as much as possible because there are the channels already there. The Wi-Fi typically already provided by the operators. The network entry is by the operator, so the combination can be there. And it shows that also the operator can basically increase the ARPU if it deploys fiber to the room. Just quickly again, sort of why this fiber to the room is needed. You see it basically at the bandwidth. Here's the example where you have like 1 gig coming to the home for like one stream. If you have several walls and things, the mesh Wi-Fi doesn't work anymore at one point in time. You probably end up with 20 meg or lower at the terminal or at the PC or phone. But if you go fiber to the room, since you cross the walls and so on, basically the fiber to the room systems can get the full speeds. This is getting even more important with the coming Wi-Fi generations because there's a lot of talk going higher frequencies in Wi-Fi. Higher frequency means you have even lower means to cross walls. So fiber to the room is very important, having high-speed access plus fiber to the room, and if you go for higher frequencies on Wi-Fi. Then with this fiber to the room system, we also improve a bit of the we can optimize it. Specifically, the Wi-Fi can be optimized. If you have fiber to the room, you have a very low latency channel in the fiber. You can basically control the different Wi-Fi access points and do that not over the air, but do that through the fiber. So you have one controller there controlling all these different ONTs. That basically gives all these good benefits, having no packet loss, very ultra low latency, much higher concurrency, many more devices can connect for IoT applications, and it have much higher rates. And then there are several product shapings going on there. So to sum up, F5G Advanced is basically looking into fiber to everywhere and everything. Don't need to preach here about the good thing about fiber. F5G Advanced, the key technologies I was talking about here is 50G PON, high-speed OLTs, Wi-Fi 7, and advanced FTTR. So these are the things I was just showing. There are a lot of other technologies needed for the overall system. And sort of the key features, probably if you want to say so, it's that the intelligent autonomous end-to-end management is needed. Now you have home, access, and core if you look into the backhauling of the OLT. You have power-saving mechanisms at addressing the green aspect, and you have operator-controlled Wi-Fi in cases this is allowed. With that, I close here, and thank you very much.
Okay, thank you, Marcus. And guten Morgen, warm welcome, goedemorgen. I'm from AVM, and AVM is probably well known in Germany for the Fritzbox. A few years ago, our CEO tried to explain on the CeBIT what's a Fritzbox, and Frau Dr. Merkel was visitors. Forget it, hat doch jeder, or everyone has it. That's our position here in the German market. But anyway, we heard a lot about open standards and about new things what we are coming up in the network. And for AVM, we have a role as well in there. Why? Because we think it's very important for the end customer, the whole system, from the high speed entering the door until the end device, that's the whole picture. That's causing the phone calls at the help desk. That's why we think it's very important that the performance in CPE can handle the high speeds as stated by some other speakers over here. And last but not least, we do as well believe in open standards. It's important that you can manage the whole core network, the whole CPE, and everything in between and the end device by an open standard. We don't believe in proprietary solutions because proprietary solution has locked in and doesn't bring us as an industry forward. What is from our point of view, one of the key elements we see for doing this? Coming from the broadband form, there is a standard called TR369 or USB. And with USB, you are able to monitor and manage a lot of elements from your network, from the whole system, starting from what's delivered by the provider on the fiber or DSL or DOCSIS or whatsoever, and to what's delivered to the end device. And providers can monitor it or can control it by using this open standard USB. USB is probably as well known as the next thing of services like TR69. Most of the ISPs are using TR69 by enabling and to do the provisioning of their CPEs at the end customers. That's the more. And what we find out is that there is a little bit of, how do you say it, a battle. Maybe that's the nice word we have. There's a battle between the guys from the fiber network, they want their information, and the guys are running into the system. In this case, the end device wants to know what's happening. And to manage this in one system, you can do this with USB, or in this case, TR369. And this avoids to have several systems doing the same thing. I'll give you an example, because this makes it more easy to understand. By using USB, as an industry, you are able to use several controllers. In this case, you could say, okay, I need one controller, particularly only managing the broadband connectivity. He's only looking what's coming in from the fiber line, or what's coming in for a DSL, and what's coming in from the DOCSIS line. Again, this is not only particularly for fiber networks, it covers the whole broadband technologies, even 5G if you like. Hey, with this standard, you can use and you can manage the complete system, you can use and manage the whole environment. The second thing is that we all heard, probably here as well, that people want to use apps, running apps on doing things. What things? I don't know, do things. And for this, the problem is for as an industry, as a vendor, then we have to enable things in our box so that apps can communicate to a box. And we think the better solution is that we have apps, they are communicating to the USB system, and the USB system is communicating to the, in this case, the Fritz boxes. Because that makes it more easy, and in this case makes it more standard. So that means everyone can build, because USB is a standard coming from the broadband forum. So this is not only for AVM relevant, but it's for every CPE vendor is relevant. By using these standards, we are opening our doors without touching our own system, our own software. We're opening just the doors for other vendors so they can monitor and control services in the local network and control and managing the hardware on a standard way. And that's why we are promoting those standards. That's why we think this is the important thing to go forward. Go away from proprietary solutions. Go away from just a system, just managing the fiber line, or just managing the DSL line, or just managing the DOCSIS line. Go away. That's history. It's not working. We already heard, again, also in the presentation from Marcus, that we bring those high speeds forward to an end device. Bringing in multi-gig fiber solutions to an end device. But if I look to my own mother, she will call the help desk and say, internet is broken. Yeah, I don't think so. The internet is broken. Just a part of her experience is broken. And probably the connection between her tablet or whatsoever to the first access point or to the router, that part is broken. But the common customer will call and say, yeah, internet is broken. So from the provider side, you want to know, you want to learn what's happening. More or less, you want to have a heat map. Okay, this tablet is connected to an access point. Is this access point well connected to the router, or do we need to bring them more closer, or is it disturbance, and so on and so on. With USB, you are able, as a provider, to monitor and produce those kinds of heat maps to see what's happening on my network. And with this, you can help on a standardized way, on a standardized method, your customers to bring them again online. And so they can benefit of the high speeds we are delivering by using new fiber technologies, even in higher speeds. So our vision, our idea is that you have to have a look, or the ability to have to look what's happening in home. That you can help your end customers to keep online with the best services as possible. And USB can help you with that. As already said, there's only one part of the story. The other part of the story as well is that you want to know, okay, what's happening on the line? What's happening on the outside line? The most easy way, as we see it, using integrated devices. So no split of an ONT and a router, but use it in one integrated devices and have several controllers for managing the complete system. In other words, when I'm using one system, there's an integrated device as a CPE, and that's what we're doing on the DSL, that's what we're doing on the DOCSIS network, but someone thought it's a better solution to have an ONT. Again, just a modem. We have been there, done that in the past, and we're using on the DSL networks and on the DOCSIS networks, we always use integrated devices. So my vision is, and not only mine, but also for AVM, please do it as well on the fiber networks. We learned already from the other technologies. But as already said, and also was seen in the Open Networks presentations, we want to know what's happening. What's the quality of the line? What is there signal loss? And so on and so on. We want to know the quality. Even for that, we can use the USB standard. A few weeks ago, we talked a lot, Marcus was there as well, at the Broadband Forum, about the standards and how we can implement all those fiber optics information into the data model so that you are able, on a standard way, again, standard way, to see and look and have a feel what's happening in the network system. This is for the technology freaks under us. Some elements we introduced in the data model. I don't go in all my detail, but to give you an example, you're able to monitor your CP, you're able to monitor your line, you're even able to look what kind of ONT is connected to the system. It's all in the standard data model as presented. As already said, standard, standard, standard. We're not alone there. There are a lot of other companies that are doing this. And with those suppliers, you are very easy, and I encourage you to visit them. They are here at the fair as well, to make those things happen. We already did it. If you look at here in German customer, large ones, over 1 million Fritz boxes running and controlling in a mixed environment in using the USP technologies. It's not rocket science. It's already there. We did it. Go forward. Next step. Next big thing. With this, I want to thank you for my short presentation. Hand over to Patrick for the next part. Thank you very much.
Thank you, Eric. Thank you, Eric. Well, thank you. Thank you for our panelists. Very interesting information, very interesting outlook. We heard a lot of things. We heard a good story flowing end to end through the network all the way to the home. The aim is to enhance the end user experience. The aim is really bringing fiber everywhere, bringing high speed all the way to the inaccessible areas, let's say, in the home. I will open the floor for questions from the audience. We have about 8 minutes, so we can take a couple of questions from the audience, and I hope there will be a good discussion further. Is there any question?
Yes, thank you for the presentation. I'm Tony from Huawei France. Because in Marcus' presentation, he mentioned the FTTR, the fiber to the room. So for the other speakers, how do you think about this kind of evolution that beyond FTTH to FTTR, especially for like talking about management USP, you need to actually also manage the devices in the home. And also Marcus also talking about the coordination to the Wi-Fi between the fiber and how this USP can actually help. I think that maybe the speaker can give your ideas that for the FTTR, like the fiber extended to the room, so what's the challenge there, and what will be the good things or bad things, and what we need to do to actually help this fiber extension in the future? Thank you.
Very interesting question. Thank you for that. As said, at this moment within AVM, we're using the Wi-Fi technology because this fits to the current situation, the current market situation, if you look into Europe and even if you looked into speeds. With this, I do again, we heard it as well, the promotion of introduction of Wi-Fi 7, because Wi-Fi 7 with the new standards defined and the whole speeds brings us for the near future a lot of more benefits. I do agree with Marcus, if you are even the next step, if you higher the frequency, it will be the next relevant element to have a look, okay, how can we bring those speeds to several rooms? There are several technologies we use as well for the more lower speeds, up to a couple of 100 meg. We use a power line within our system. We have the fiber to the home solutions. The Wi-Fi, sorry, Marcus. We have all those elements. And of course, we are a technology company, and then we have a look as well, okay, how to distribute those higher speeds in the next step for. But as we have now, and we're now the current European market where we're focusing on, with the technology we offer, and even with the upcoming Wi-Fi 7, is more than enough to reach and to enable the speeds and to deliver the speeds at the end customer devices at this moment.
Thank you, Eric. Any comment?
Yeah, perhaps also from our side, for sure, optical fiber is the best media we know. So it gives us a big capacity, no influence from other outside environmental aspects and so on. It's really the future medium. So we all believe on this. The conference is based on the fiber technology. However, FTTR, we see that the biggest challenge is actually in the deployment of the fiber at home. So you need a technician that visits you, that glue the fiber to each room. It takes some time. It's a cost, and it will take some time that this will be massively deployed also to other countries. So we've seen that China is leading here. So we will see how the other countries are following. Till then, I agree with Eric. So Wi-Fi 7 is bringing a big upgrade from previous technologies. It's very easy to install. You just deploy the device, and it backhauls wirelessly. So it will be an interesting development to see how this FTTR implementation will be implemented in different countries.
Okay, Kaisa?
Yeah, we've been looking into this, and we actually have a paper on it for review. But I think you have to go back more than the propagation. You have to look on the use cases. And I think that when you start to have meta services in your house, this is where you need like the sync between the up and the downlink, where it starts to make relevance. So as the other speakers say, for time being, we are very good with the Wi-Fi standards we have, but as the use cases come, of course.
Yeah, I mean, linking all that to Germany, I'll get you, Markus. We are struggling with convincing people with fiber to the home. When are we going to be able to push the limit and say, okay, you need fiber to each room even? And Markus, I'll let you comment last thing. And we're talking about open technologies. Are we also developing fiber to the room in a way where we also enable open technology on top of that fiber to the room, or everybody is going to come with their own fiber to the room small in-house network, and it's becoming overbuilt in the house as well? We don't want that. I think we all agree that we don't want that. But Markus, last comment on that before we get another question.
Let me make one comment to the fiber deployment in the home. It's not that difficult. We have cases where we have mass deployment of fiber to the room. It's 1 hour per house.
Yeah. No, I agree. Passive components that are advanced.
Passive deployment is doable, depending on how you do it. Then coming back to the openness, naturally fiber to the room is actually under standardization.
Okay.
I think the baseline standards, sort of the on-fiber interface standards, are consented in the last ITUT meeting, the end of last year. F5G has standardized the overall architecture of fiber to the room. What are the interfaces? What do you need? In F5G, we are actually now looking in the fiber to the room testing activity. So also, like, the standards are there, but we also want to have testing and see whether things are interoperable. So it's open specification, open interfaces. There's no lock-in in that sense on that technology.
Thank you. It'll be very interesting to see when this need will come. Any other question from the audience we have?
Hi, Enda Finnan from the Irish regulator. I was wondering your thoughts on the timeline for widespread deployment of 50 gig and of SDN in the access network.
On SDN, I think depends a little bit on what you say SDN.
Well, first slices are replacing leased lines, for example, or wholesaling to third parties from a wholesale network.
Yeah, so F5G is specifying what we call F5G slices, which basically are virtual networks which can be opened and give out to different players. So the question is always on what level you have the separation and the virtualization happening. There are different ways of doing that. 50G PON, I mean, I showed our products are available. you can start basically installing it. There are several operators who started installing it. Naturally, not at scale yet, but it's sort of this thing is starting. What we see is really the more, I'm saying, more high-end, small, medium enterprises segment, which goes first, because they need more capacity, and the key is that we have a multi-service platform in the fiber network to basically deliver this type of differentiated services for the customer needs where it's needed.
Yeah, perhaps a comment about the SDN implementation. So we had a very interesting workshop on Tuesday regarding this topic, and there were speakers from various operators. So on that workshop, the operators presented their experiences by implementing SDN. So it's a mature technology. It's been implemented massively at specific tier 1 operators. So it's something that is available today.
Okay. We ran out of time. I think, is there any urgent question? If not, I think you can find our panelists on their respective booth. Thank you so much for an interesting discussion. I think, again, the aim is one, is bringing fiber everywhere, is enhancing the user experience, bringing high speed to enable all the future applications that we see. The key question is when and how fast we can go forward with that. And first, let's cross fingers for the German market to kind of start pushing the limits and get fiber to the home. I live in Germany. I'm in favor of that. And thank you so much for the audience. Thank you for the questions. And have a nice rest of the day with interesting.
Thank you very much.